In this video, we'll be working through the question you see on the screen from the 2023 Ordinary Level Maths Leaving Cert. I recommend you try the question before watching, and if you get stuck anywhere, feel free to ask for help in the comments. I will do my best to get back to you. Check out my channel for a playlist with all the other questions. And this is question 7, the first of the long questions in the paper. It's made up of multiple different parts. We have a bit of algebra, a simple enough algebra, a bit of differentiation, again quite simple, a bit of probability, quite simple. It's putting it all together makes this an actual difficult question, especially when twice in the question they're going to ask us to explain what we're doing. That's the bit most students fall down at. I'll do my best to explain it, but it's actually quite hard to teach in a short video. But let's get started. Question 7 part A, they first give us a bit of a story about rain, runoff rate, and what's S there, the maximum amount of rain in the soil. Honestly, usually it's a simple enough scientific little story. It happens every year, multiple times every year. They'll invent some sort of case just to give you a formula. This case, it's actually I don't fully understand what the runoff curve is or anything like that. And that's going to happen lots of students where I don't understand this science. But you don't have to understand the science. The maths is actually quite simple, and that's what I'm going to show you how to solve today. So in part 1, they simply ask us, forget about any of the science or any of the English words, they just ask us to find C when S is 15. So we know S is 15, find C. So we just go ahead and write C equals 1,000. They're telling us what C is, it's all right here. C is equal to 1,000 divided by S, but now we know what S is. S is 15 plus 10. And we just go ahead, 15 plus 10 is 25, that's 1,000 divided by 25. Use a calculator, that should go in, I believe, 40 times. And that's it, that's the answer to part 1. We don't need to understand any of the science there about rain runoff and how much rain soaks into land. They're just asking us the maths here. Okay, for part 2, they tell us that S increases. So S increases, and they ask us what happens to C. Does it increase or decrease? And then it asks us to justify our answer. This is one of those really hard questions. I'm guessing lots of students got the first part right, and the justification, they probably lost marks. So I'll show you what I would do here. First, there's a few maths ways to do this. I'm not even going to show you it. I'm going to show you what I think most people should do in this sort of simple question. Just guess some answers. They tell you S increases. So let's put in some answers for S. 0, 10, let's say 1,000, and let's say 1,000,000. We're going to assume that S is positive, so no minus numbers. They didn't tell us that, but this is a science question. They told us S was the maximum amount of rain that could go into land, so it couldn't be a minus. Still, we're going to put S as all these. Let's put S here. And then we're going to work out what C is. So we're just going to do the same thing we did here a few times. Now, you don't have to do any of this. You can just guess the answer. If you know how to do the answer, you can just do it. This is how I would go about showing someone. I'm just going to do the same thing here with all these numbers. So I'm going to put 0 in. 1,000 divided by 0 plus 10. That's 1,000 divided by 0 plus 10. Well, that's just 1,000 divided by 10, and that's just 100. I'm going to do the same all the way along. I'll do it a bit faster. 1,000 divided by 10 plus 10 is just 1,000 divided by 20, which is 50. And put 1,000 in. That'll be 1,000 divided by 1,010. Put that into a calculator, we'll get 0.99, something like that. Round it off, it's 1, pretty much. 1,000 divided by 1,000, pretty much. Put in 1,000,000, we get 1,000 divided by 1,010,000. Put that into a calculator, we get 0.001, I think. I might be wrong on that. Probably 0.0099, something like that. We'll just go with 1. So what's happening to C? S is increasing What's happening to C? 100, 50, 1, pretty much 0. We'll call this guy 0. What's happening to C? It's decreasing. So S is increasing, D is decreasing. And that's the correct answer, but then they ask you to justify it. Now, one thing I would say is, this is just a bit of justification. If you wrote some of these sums in the area below, I think you'd probably get full marks, but to be sure to get full marks, what they're really looking for is a bit of English, and it's something along the lines of when they say denominator and numerator, but I'm just going to say top and bottom. They'd say something like the top stays the same, top is the same, and the bottom, look what's happened at the bottom. S plus 10 is 10. It's, 10, 20, 1,000, 1,000,000. It's increasing. The top stays the same and the bottom is increasing. That'd be enough for them, actually. They don't really need a sentence in English. They just want you to show that the bottom is increasing more than the top is. The top is staying the same and the bottom is increasing. That makes the whole thing decrease. But really, this little bit of science here, guessing an answer, checking your answer, seeing how it works with other answers, is probably good enough as well. In part 3, they want us to write this equation again, but they want to write S in terms of C. That just means they want S equals something with C in it. Okay, so let's go ahead and try and do that. We'll do that by moving things around. We would like to move this S. We want it on the top row somewhere, maybe over here on its own. So you might think, S is dividing 1,000. Let's multiply over here. But you can't quite do that yet, because S is working with 10. S and 10 are joined together and dividing 1,000. You can't move one of them out until they finish this job of dividing. But we can group them together and move both of them. So we're not really moving. We're going to multiply both sides by S plus 10 and multiply by C on the left. And the right side, S plus 10 multiplied up here, will cancel. They'll just cancel out. I'll often just say moving, but that's what I really mean. Okay, so S, we're getting closer to getting S on its own. It's now on the top row at least. It was horrible on the bottom row here. But still, there's lots of things in the way. 10 and C are in the way here. We can't move 10. Again, it's locked in with C, with S multiplying C. So we can't move it yet. We can move C. It's out here on its own. It's multiplying. So we will divide both sides by C. Divide the right by C, divide by left, it cancels. Okay, now the 10 is not acting with anyone else. It's not locked in with anyone else, I should say. It's adding onto the S. So we'll take 10 away from both sides. We'll get 1,000 over C minus 10. And that's the answer. Just a couple of things to warn you about. Lots of mistakes students would probably make here at the end is S is equal 1,000 minus 10 over C. That's not correct. You take 10 from both sides. The right side was this whole number. You took 10 away from it. This, you haven't taken 10 away from the right side. You've taken 10 away from 1,000 and you've ignored C. So that's a mistake lots of students would make. And then the other thing is, this is correct, this is full marks, but some students would also write this like 1,000 minus 10C over C. This is also full marks. If you don't understand how to get from this to this, that's okay. If you do understand, well then you probably don't need me to explain it. It's really, how we get from here to here is just by adding a C, top and bottom, to this number. So I've done nothing. Multiplied and divided by the same number. It's like multiplying by 1. So really I've done nothing here. That's how they're the same. We can just add 1,000, take away 1,000 minus 10C is 1,000 minus 10C, and they're both over the same number. Okay, but I'll rub this out for now. And this is the number we'll probably use in the next part. Okay, in part 4, they tell us to use our answer from the last part, which that's why I've written this here. And they tell us the values of C goes from 30 all the way up to 100. And they ask us to find the range of values for S. So really we just put in numbers, the C numbers in here to find for S. We could put in lots of them, but we're just going to put in 30 and 100 because we already seen what a world like this looks like. These are fairly similar. 1000 divided by one letter, that's positive. In part A, we seen that as we put in numbers, it just got smaller. So as we put in bigger numbers for C, we expect S just to get smaller. So that means I don't really need to put in the first two. I'll show you what I mean by that. So I'm going to put in S is equal 1000 over 30 minus 10. And then I'm going to put in S is equal 1000 over 100 minus 10. You can go ahead and put in more numbers if you want, 30, 40, 50, 60, just to test out the experiment if you want, but I'm going to show you that this works fine. To do this, 1000 divided by 30 is, checking a calculator, but I believe it's 33.333 minus 10, which is 23.33, and that continues on. This number, 1000 divided by 100 is 10, minus 10 is equal to 0. So these numbers should, as C gets bigger, this should get smaller and smaller. So this must be the biggest number because it's the smallest C, so S must be the biggest. It's the biggest C, so S must be the smallest. So the numbers first of all, this might feel like enough answer, but you would lose marks by just writing this. At the bottom of the page, they do want you to write in, I think it's something like range from 0 to 23.3. Something like that. It'd be okay if you wrote 333 or even just 3. I think 3 significant numbers is usually enough. They take marks away if you wrote 23 just, or 24. But 23.3 you'd be fine, but put in as many as you want. Okay, so that's part A, and we'll go on and do part B. Okay, in part B they tell us another story with some numbers, a little bit of science. They tell us we have a town called Waterville, which we're going to find out rains a lot in Waterville, so it's an apt name. So it's a town called Waterville, and they tell us that P is the probability that it rains any time during the day, where T is the time past midnight. So at midnight T is 0, at 1 in the morning T is 1, at 9 in the morning it's 9, at 5 in the evening it's 17, and at the next midnight it's 24. Alright, and if we put those numbers in, change T here and here, we'll find the probability that it rains. So that's what they're going to ask us to do. In part 1, they ask us to find the probability that it rains at the start of the day and the end of the day. And they help us by explaining that's P0. P0 is the start of the day. So we're going to put that in, equals 0.3, nothing changes there, plus 0.02 multiplied by 0. So what's that equal to? 0 multiplied by anything is 0. So that's just 0.3. And you can write this, by the way, probability 0.3 is the same as percentage. We use percentage in real life more. I say there's a 30% chance that it's raining at the start of the day. Or you can say it's 0.3 probability it's raining. These are the same. They mean the same things. They also then ask us to find P24. This is the end of the day. So we do, it's all the same. 0.3 doesn't change, plus 0.02, and T. T is the only thing that changes. Turns to 24. We put this in a calculator, we get 0.3 plus 0.48. Add that together, we get 0.78. Or another way to say that is 78%. So at the end of the day, it's the chance it rained at some point in the day, isn't it? Yeah, okay, so it's a 78% chance that it rained at some point in the day, not exactly at midnight it's raining. It's a high chance of raining at midnight. At some point in this day it did rain. At the start of the day, at some point in the day, which has only just begun, it's only 30% chance of rain. So that's what these numbers mean. Okay, for part 2. They ask us to find p prime t, the derivative of t. So here is pt. We just need to differentiate this. So this should be quite straightforward. The derivative of 0.3 is just 0. It's just a number. It doesn't change. So that just disappears. The derivative of 0.02 multiplied by t is just 0.02. So remember, the t just disappears when we differentiate against a single variable. Yeah, I'll go in more detail on that, but that's how most of you guys think of that. The constant disappears, the t disappears, and if there was any t squared, then we use our rules. But for now, that's the derivative there, 0.02. Now the really hard part of this question, because that should be quite straightforward, they're going to ask you to differentiate 2 or 3 times every exam, and this was a fairly easy one. So this should have been quite easy for most students. The really hard bit was the next bit where they say, explain the meaning of this. I'd say very few students got the right answer. So for this, my first bit of advice is to just write down everything you can think of differentiation. Don't spend more than 3 or 4 minutes, but still write down whatever you think you remember about differentiation. The examiner is really nice. If you write anything that's wrong, they'll ignore it. And if you write anything that's correct, they'll say, they're correct. So that's really good in your exam. That's a little cheat for the exam. But the real answer here is differentiation is the changing of something. How much does this constant number change? It doesn't change. It's always 0.3. So the derivative of that is 0. How much does this guy change? Well, it changes 0.02 every time. That's how much it changes. And that's what the differentiation tells us, how much something changes. So this entire thing, pt, how much does that change? That's what the derivative is. It changes 0.02, or a little more correctly, we'd write something like changes 0.02 every hour. Ran out of room there a bit. Every hour. So that's what this means. That's what this number here means. Every hour, the chances of it raining is increasing 0.02. Yeah, I could have wrote that as well. Increases. Yeah, maybe I'd write that. Chance of raining increases by 0.02, or you could write 2%. Every hour. That's probably, both of these would be fine, but that's full marks every hour. Okay, so that's part 2. I'll rub this off and we'll do part 3. But if you knew this, if you got this correct, congratulations. Very few students probably would have got the second part of part 2 correct. Okay, on to part 3. They tell us that at some point in the day, the probability is 0.35. And they asked us to basically find out what time this happens at. But they are very tricky about it. They tell us that they want to know what's the probability exactly 1 hour later. So what they're really asking is, what time does this happen at? And then we'll add 1 hour onto that. That probably tripped up a lot of students in this question. So the probability of 0.35, let's find out what time that happens, and then we'll go back to the question and deal with that. So, I rubbed everything out and I got this number wrong, it looks like. 0.3 plus it. So let's go ahead and write this formula again. 0.3 plus 0.02t, and we know the answer this time. It's 0.35. They tell us at some point this is the probability. So let's find out what time that happens at. So we'll just let's rearrange the equation so we get t on its own. We want to get t on its own somewhere down here. You know, don't write this first, but that's just something I do as a teacher. So to get it on its own, let's just get rid of these other numbers. 0.3 is very simple, it's just adding this side. So let's take away both sides. So 0.02, we'll take this away, it'll disappear. And on this side, we'll take it away as well, minus 0.3. And that'll become 0.05. And let's write this again, 0.02t. Okay, we want t on its own. Let's get rid of this guy. He's multiplying t, so let's divide both sides. That'll cancel on the left, and on the right we'll get 0.05 divided by 0.02. Lots of students seem to panic when they have a division like this. You have a calculator, just go ahead and use the calculator. I know it looks weird with all the decimals. Put that in a calculator, you get 2.5. And always check your answer if it makes sense in your head. 2.5 hours, yeah, that's a normal. We want the time to be between 0 and 24. That works. Probability was 0.35. Earlier at 0 hours we found the probability was 0.3. And we also found out that it moves this much every hour. So that works as well. 2.5 hours later it will get there. You could probably have done this in your head if you understood the first two parts much better. But here's the trick of the question. They didn't ask you to find this time. They didn't. They asked you to find the probability, P, the probability 1 hour later. So not at 2.5, they want the probability at 3.5. So very tricky question that. But we do this just like in part 1, was it B part 1 we did? We just use this formula and change t. So 0.3 plus 0.02 multiplied by 3.5. We go ahead and put this in a calculator as 0.3 plus, I don't have a calculator so I'll just do it in my head, I hope, 0.07. We add that together, we get 0.37. Or again, we could write that as 37%. So that's the probability that's reigned in the first 3.5 hours. And that's it. That's all for part 7. Very, very hard question, I think, because it had lots of little parts that tried to trick you, that asked you to understand things. Hopefully I was able to explain it okay. If you have any questions though, please leave them in the comments below and I'll do my best to answer. Thanks and have a great day.